Hello students, welcome to the sessions of lectures of Mathematics-02. In the last session, we have seen how to solve the first order higher degree differential equation by solvable for P. Same manner, in today's session, we are going to solve the higher degree differential equation solvable for Y. Now, suppose you have method of solvable for y, equation solvable for y. Suppose you have y is equal to some function of x and p. Okay, then differentiate this with respect to x, that means dy by dx, that is nothing but your p, which is equal to some function phi of x, p and dp by dx. Okay, now this is the equation number 1, this is the equation number 2. Suppose let some capital F of x comma p comma c is equal to 0, equation number 3. This is solution of equation 2. Then the solution of equation 1 is obtained by eliminating p from equation 1 and 3. Okay. Now, it may happen that you cannot eliminate. Note, if p is not able to eliminate, then we have to write x is a function of p and y is some another function of p. That means you have to write down x and y in a parametric form where p is a parameter. Okay, this is the first one. Second one, if the factor does not contain dp by dx, then ignore. That means in equation 2, once you are going to factorize and the factor is not containing dp by dx, then we are not going to consider it. Okay, for solution. These two are the important notes that you have to remember. If elimination is possible, then you must have to eliminate p. But if it is not possible, in that case, we are writing our answer in a form of p. So, first example we have written is y plus px is equal to x raised to 4 into p square. Now see, here the factorization is not possible. So, y plus px is equal to x raised to 4 p square. So, I am differentiating with respect to x. And that will give you dy by dx plus, here you have to apply product rule, x as it is dp by dx plus p, x as a derivative 1, here x raised to 4 as it is, p square as a derivative 2p into dp by dx plus sorry 4x cube into p square. Okay, but dy by dx is nothing but it is your p. So p plus p, that is 2p plus x into dp by dx is equal to 2x raised to 4p dp by dx plus 4x cube p square. Correct? Now from left hand side, here I am going to common out 2x cube p, and that will give you x dp by dx plus 2p. Correct? So 2p plus x dp by dx. Now write down this is equal to 0, and that will give you 2p plus x dp by dx minus 2x cube p into x dp by dx plus 2p is equal to 0. So x dp by dx plus 2p into 1 minus 2x cube p is equal to 0. So here you have two factors, but this factor does not have a dp by dx. So we are not going to consider it. So we are only going to take x dp by dx plus 2p is equal to 0. See, we are only going to consider this factor. So if you are writing this, then it is x dp upon dx is equal to minus 2p reduced in a form of variable separable. Dp upon p is equal to minus 2 dx upon x. So integrating both sides, that will give you log p is equal to minus 2 log x plus log c. As both are in a form of log, so I have written it in the form of log c. So this can be written as log c upon x square is equal to log p, and that will give you p is equal to c by x square. Equation number 2. Now your original equation is this. This is equation number 1. Y plus px plus x raised to 4p square. So y plus px plus is equal to x raised to 4p square. Here substitute this value. So putting value of p in equation 1. Value of p in equation 1. This is your equation 1. So you have y plus c upon x square into x is equal to x raised to 4 into c square upon x raised to 4. And if you are going to simplify, so that will give y plus c upon x is equal to c square. So this is the answer of your equation. Here you can eliminate your differential equation. That's why we have written it in this form. So this is the solution of given differential equation. This is the required solution. Now we have taken one another example. What you have? Y is equal to 1 plus p into x plus p square. So again differentiating with respect to x. So dy by dx is equal to, here you have to apply product rule, 1 plus p as it is, derivative of x is 1, x as it is, derivative of this one is dp upon dx, plus this one is 2p into dp upon dx. So this is nothing but it is your p, dy by dx. So taking this pp will be cancelled out, correct, and that will give you dp by dx into x plus 2p plus 1 is equal to 0, and that will give you, I am going to write this in a form of, see, this is not directly solvable, so I am going to multiply this in a form and writing this in a form of dx by dp plus x plus 2p is equal to 0. So you will have dx upon dp plus x is equal to minus 2p. So this is your linear differential equation in a form of x and t. So capital Px is equal to 1, capital Qx is minus 2p, integration px dx, that will be a integration of 1 dx, that will be a, sorry, instead of, it will be a p of p, q of p, p of small p dp, so 1 dp, and that will be a small p. Okay, so your if is e raised to integration capital P of small p dp, and that will be a e raised to p, and therefore the general solution is, instead of y, now you have a variable x into if is equal to integration q into if dp plus c, as now variable is small p. So x into e raised to p is equal to integration, your q is nothing but it is minus 2p, so minus 2p dp plus c. So integration of this one is minus p square plus c. And see, from this equation you cannot find out the value of p in the form of x and c. So you have x is equal to e raised to p. So x will be minus p square e raised to minus p plus c e raised to minus p. Done? So this is in a form of p. Now put that value here. Put that value here in equation 1. So putting value of x in equation 1. So you will have y is equal to 1 plus p into minus p square e raised to minus p plus c e raised to minus p plus p square. So simplifying this one, that will give you, if you have to simplify then simplify, otherwise put it as it is, that will also give you the answer. So this is x in the form of p, y in a form of p. So equation 2 and equation 3 are solution of equation 1. See, here you cannot eliminate p from equation 2 and equation 1, correct? That's why we have written the answer in a form of parametric form, as e raised to p cannot be simplified in a form of x. Done? So this is the answer of your given differential equation. So these two cases you have to remember in the case of solvable for y. The same thing we are going to do for solvable for x. That we are going to discuss in the next session. Okay. So these are the topics which we have covered in today's session. So please, if you have any doubt or any query regarding this topic, then please feel free to contact me. Thank you so much for watching me.